Woohoo, we are live. This is Math 60, section 1.3, operations with real numbers, part 1. And the exciting thing in it is that in 1.3, we're actually going to do some math. I know you're all very excited. Most of this is going to be arithmetic. We're still kind of sneaking up on the algebra part, but it's really important to make sure that everyone is really solid with the arithmetic before we go racing off and try to do a bunch of other things. So let us talk about square roots. Woohoo! So what are the square roots of 25? Now, hopefully, at some point in your life, someone has pointed out that the square roots of 25 are 5 and -5. And you might ask yourself, wait, why? Why is -5? And the answer is -5 times -5 is 25. So you can split 25 into 5 times 5 or -5 times -5. So they're both square roots. So this is why some mathematicians, when you say, what's the square root of 25, will say, well, which one do you want? And it used to be a big controversy. As far as I can tell, it's becoming less and less so. And so it's kind of more old-fashioned to worry about this, but I don't know who you're going to get for a math teacher, so I want to make sure you know that this is kind of swirling around in the dark underbelly of math. If you write the square root sign, which is known as a radical sign, this symbol is a radical. So this is a radical or radical sign. If you've got just that thing that people call the square root of 25, the radical 25, you get the +5. You pronounce it radical 25, and that equals 5. Now, what happens if you want the -5, the -5? Well, then you have to put a minus out in front or a negative sign out in front to tell people, oh, I want the -1. And this technically is pronounced the opposite of radical 25. Now, do people say minus square root of 25 all the time? Yes. Will you even hear me say it? Yes. Sometimes I'll say it. I use a lot of different language to try to, bring everyone together. So, but technically it should be the opposite of radical 25, just so you know. Now, you can also call this the principal square root of 25. And you could call this the negative square root of 25. What does principal mean? Main. So principal or positive square root of 25, the negative square root of 25. You could also say it that way. So, and I just wanted to point this out. There's a lot of language. Now, for me, what language can you use? Heck, if you'll talk about math, I will accept. I have a very low bar for language. However you want to describe it to me, we're golden. Many folks say square root of 5. But if you do want to be formal, make sure you use the term radical. Or use principal square root or positive square root or negative square root. Okay, it's more terminology. If I have, and this little tiny, let me write it bigger, little tiny numbers. Hopefully it's a little bit bigger. This is 3 to the 4th power. Now, to be honest, a lot of people don't say the word power. They just say 3 to the 4th, and that's acceptable. So 3 to the 4th power or 3 to the 4th. In that, 3 is called the base, 4 is called the exponent. On the calculator, dun, 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 you will not always have an obvious exponent key. especially with Texas Instruments, if you were able to look at all these keys, you'd be like, where is the exponent key? I don't see it. So sometimes you're looking for an x to the y or a y to the x key. That's common. But the other one that is common that people don't always recognize is this guy called a caret. Looks like a mountaintop or a rooftop. And on my calculator, that's what I have. And I don't know if you can see it. It may be too small, but it's right there. It's that little rooftop, mountaintop guy. So I would type in the number 3, then my caret, my exponent key, and then 4, and then equals, or mine says enter and equals. Some calculators just say equals or just say enter. And 3 to the 4th, it's 4 through, oh, what was I thinking? I'm just got equals on the brain. If there are 4 3s, 3 times 3, so 2 of them over here is 9, 2 of them over here is 9, 9 times 9 is 81. 3 to the 4th power is 81. Woohoo. So here's some stuff about just terminology that will help you with the section. And let's start working on something called order of operations. So we're going to start off, and I'm going to talk about math again. Well, that's pretty much my only job, is to talk about math. Sometimes economics when I get lucky. So math. Math has been around for a very long time. People have been doing math to count stuff, keep track of things for basically, as far as anyone can tell, as long as there have been people. Math got a big boost with the ancient Greeks, who were working with a lot of geometry, and that was very exciting. And then another big boost in about 800 when someone in Persia wrote down some algebra, wrote a book. There have been significant jumps, leaps ahead, some falling backwards, some losing stuff, them finding it again. And the thing is the whole history of humans before telephones was quite significant. All right, telephones are fairly recent. Telephones are in the last couple hundred years. So most math through the history of math had to be written down and either shared with someone in person or written down in a letter and sent to them. So you send them a letter, or you would publish a book. And in order for any of the math to make sense, everyone had to agree. Now, you might think that all mathematicians agree. They do not. But there was an agreement about the order of operations. And basically, this was an agreement that we're all going to agree that there's a certain way to do things, because otherwise, when you try to figure out what someone has written in their letter to you, it will just be chaos. It will just be gobbledygook. So my example for this, our first example, is this very simple problem, 8 minus 4 times 2. And the question is, what does that equal? Very simple problem. I didn't even use algebra. It's all arithmetic. Didn't even divide, no fractions, no zeros. So it's very simple as math goes. And so the question is the correct method to do the first thing first, 8 minus 4, so that I get 4. So the 8 minus 4 became 4 times 2 is 8. Or should I do the multiplication part first? 4 times 2. That gives me an 8. So I've got 8 minus 8 is 0. I get 2 different answers, depending on whether I do this one first and then this one second, or if I do this one first and this one second. So they're opposite directions. Do I go left to right? Do I go right to left? What's the deal? And so this is the set of rules. That's what we're about to teach you, or try to. Now, order of operations is something you study over and over again because it is not easy. It is just a list somebody else decided on. So here's that list. The order of operations start with grouping symbols, parentheses, brackets, braces, and absolute value. And these are the ways that we can make notation in the math to say, nope, do this first. This is the important thing. Look here. So, and there are at least 4 different ways to set this up, and possibly more. We're just not learning about them right now. So grouping symbols comes first. Then second most important is if you see an exponent, you do the exponent. Third level, division and multiplication. I wrote them backwards. A lot of people say multiplication and division, but that leads some people to believe that they have a mysterious rank, like multiplication is always more important than division. And I've got a secret for you. The secret is that multiplication and division are basically the same thing, right? They're just, one is the backwards version of the other, but they're basically the same thing. One of them shouldn't be more important. But the problem is if you got a bunch of them together, you got to decide who's going to come first. Which one do we work on first? And the answer is because the language, the languages that we've used, that we've inherited, so the math that we're studying here in San Francisco comes to us through a bunch of languages that are read left to right. Like Greek, Latin, French, German, English, some others, Spanish, all read left to right. If you put your hands palm down on the table, your left hand will make an L. So from this side to this side. So we're always going to work left to right. So that's how we decide division and multiplication, who goes first. And then the last level will be the addition and subtraction. And trust me when I say, I know subtraction and addition seemed like they're really nice to you. They're not. They're evil. They're plotting world domination, and they're going to make your life miserable. And we get to study them over and over again in this class. I'll bring you over to my side, trust me. And also, if we get a bunch of them, don't let them pull any shenanigans. Just work left to right. Okay, let's use these rules, which if you want, you can memorize. Some people really don't like the please excuse my dear Aunt Sally, which is one of the ways that people memorize this. You could learn it that way. The way that I've suggested, graceful for grouping, elephants, don't mind solving algebra. Graceful elephants don't mind solving algebra. Obviously, you could come up with your own mnemonic, however you want to remember it. This order is absolutely true. There aren't some times when math doesn't work that way. There aren't, as many people have suggested online, secret ways to do math that are different. It really is this. It really, really is. And mathematicians don't disagree. And yes, some calculators makers have made some choices that make math teachers growl a little bit, but it doesn't mean that a calculator producer has changed all of math. This is it. This is for reals. Okay, so if I get an expression like this, what I do is first I go through. Are there any grouping symbols? No. Yay. Are there any exponents? No. Excellent. I'm down to these guys. What are my operations? I've got a subtraction, which is a level 4, and a multiplication, which is a level 3. I'm going to do the multiplication first. So I'm going to start with this multiplication right here. When I do math, I like to do math coming down. So let me write this again. Little bit bigger. And because highlighters tend to smear when you've written in ink, I'm going to underline the thing we're going to do first. I'm going to do the multiplication because multiplication is on a 3rd level and the subtraction is on the 4th level. So 4 times 2, 8 minus 8. There we go. Next line, 8 minus 8. Oh, 0. Ta-da! I know you're very impressed. I do this for a living. It's kind of a weird way to make a living. Huh? Okay, so shall we do another one? Yes, let's do another one. We love math. Okay, so this one is going to be, now this is part of the lecture. For the lecture, I just have the one example. And we're going to go through it, talk about it. And I know that that will not be enough times to do it. First off, I'm hoping, since this is a review, I will review this, and many or some or one at least of you will say, oh yes, I remember this. Okay, we're good. But if this is not enough, when you get to the homework, please, my rule is do not spend more than half an hour on any given problem. Ask for help. Ask me through Pronto, ask me through email, sign up for tutoring help because we've got excellent tutors. Get some help. Don't just keep bashing your head on a wall. It hurts your head and it actually decreases your ability to do math. So, it's win-win if you go and, have some fruit juice and sit and enjoy some flowers and, relax and then get some help. Okay. Dun, dun, dun. Notice that in this, I have put all of the things. We've got everything here. Do we have an exponent? Why, yes, we do. Do we have grouping symbols? Oh my gosh, so many. Do we have multiplication? Well, it doesn't look like it, but there's secret multiplication. Is there? I guess there's no addition. Oh no, I didn't put any addition in. Okay. So first thing I'm going to do, and this is, you're going to hear me say this more than once, I am always going to recommend you write everything bigger. And then the other thing I'm going to do for myself is I find absolute value as they print out looks goofy. So I'm going to make them really big. I exaggerate everything. Write big. If you write very small, things get lost. Things can hide. You write big, there's nowhere to hide. It's just numbers. Okay, so I have some grouping symbols here. I personally find it helpful to color code them. Again, I'm a big fan of the colors. If you do not like using the colors, that's okay. If it doesn't help you, skip it. Use stickers, use, I don't know, sounds, use music, whatever honestly helps you. So these two grouping symbols go together, I know, because they're both round, and these two go together because they're both straight, and this is an absolute value. And this with the parentheses outside and the absolute value inside is called nested. Isn't that cute? It's like a little baby bird in a nest, except it's absolute value. So it's a baby bird that's actually a pterodactyl and it's gonna chew, bite you and stuff. Okay, so we've got this absolute value pterodactyl here, and it's on the inside. So I'm going to work on this part first. The next thing I'm going to do, and I'm always going to recommend this, write the entire problem every time. This is going to really help me as the math teacher if I'm trying to look at your work to see what the heck happened. So inside the absolute value, I've got 6 minus 7. If I had $6, I spent $7, I owe someone $1. So I got -1. Okay. Next step. Still working with the absolute value. The absolute value, notice I had to calculate this amount. And now I'm going to go ahead and make the absolute value work. Absolute value of -1 is +1. Okay, does that make sense? So the absolute value of -1 is +1 right there. Okay, so that absolute value effectively got rid of the minus sign. Next up, I'm looking here and I look and I've got, okay, I'm still with my, notice I changed my absolute value to parentheses. I personally find this good and useful. Some people don't. There are other ways to work with it. So if you really hate that, talk to me. We'll find another method. So now the 1 is alone in the absolute, in the parentheses, but I do have an exponent right there. Now, next question. What is there? There is a multiplication in there, right? Anytime things are smashed together right next to each other, there's a multiplication. So a multiplication is down here in level 3. Exponent is level 2. I got to go with the exponent. So I'm going to do the 1 squared. So this is still my next step. Notice the 81 and the 80. Now, I know they are winking at you. They are totally winking at you. They're like, hey, come here. We would like to be subtracted now. Don't fall for it. Do not do it. I know it seems so easy. You could just get a 1, but that is not correct. Why not? Well, because see how 80 has a relationship with this thing in the parentheses. We're going to have to deal with this before we ever do the subtraction. Where's subtraction? 4th level. Last thing you do. So I know it seems they're just winking at you. Don't. Walk away. Or do walk away. Don't do anything. Okay, so 1 squared is 1. I write the multiplication in. This is called implicit multiplication. It's implicit because it's not written. Explicit means you see everything. Implicit means it's hidden. It's secret multiplication. But that's the rule. When we take two things and we smash them together, they're multiplied. Okay, so let's look. I've got a whole new situation. Grouping symbols. Grouping symbols. So I got to work inside of here. Now what's going on inside of there? I've got two things. I've got a subtraction and I've got a multiplication. Subtraction is down here. Multiplication is up here. I'm going to do the multiplication first. So I'm going to do this part first. Okay, so 81 minus 83 minus 4 times 1 is 4. Okay, now the subtraction is the only thing in here. Normally we don't do subtraction first, but the parentheses are saying, nope, this is special. We got to do what's inside. We got to do these guys first. Okay, so then I've got 81 minus 80. Still in parentheses, 3 minus 4. Okay, this keeps happening. This person keeps having $3. They had $6, they spent $7. Here they have $3, they spent $4. I don't know what these people are thinking. They're spending too much money. We need to put these people on a budget. Okay, it all seems, I mean, I know you start doing math, spending money. I know it happens. Before long, you've had, you wake up in a strange math class. Calculus is all over the place. Now what? What are we going to do with this? I've got parentheses, but everything inside the parentheses has been simplified. I've got a minus 1 in there. I've got a minus out here. And then I've got a mystery thing. What is my mystery thing? Again, remember, there's a multiplication there. I need to do this multiplication before I do that subtraction. Negative 80 or minus 80 times negative 1 is positive 80. But 80 times negative 1 is negative 80. So what the heck am I going to do? Well, some of you are going to do this. And some of you are going to do this. And I don't care which way you see it. You either see it as negative 80 times negative 1, so you get a positive 80 because of this thing, or you leave the minus there, and then you just multiply these two together to get negative 80. And then if I were you, I'd be like, well, those are different. And I'd say, no, they're not, because this is a minus, a minus. 2 minuses in a row. 2 negatives in a row makes a plus. I get 161. Woohoo! Yay! Order of operations. I believe the problems in the homework are pretty gruesome. So again, half an hour at most on any given problem, and then ask for some help. Work with friends, work with tutors, work with me. Reach out to classmates, put up a discussion. Say, hey, anyone want to talk about this problem? I'm really struggling. Can someone give me some hints? Lots and lots of ways to reach out. But you did it. We did it. We got through order of operations. Woohoo! Okay, next up, I'm not going to tell you because you don't want to know. It's something that rhymes with Miraction or craction. Draction? Yeah. Everyone's favorite fractions. Woohoo! Okay. So this is 1.3 part 1. You made it. It's a super long video. Sorry about that. But you guys are awesome. Math on.